Hello guys, today we're gonna begin with gate circuit combination logics. So let's start. It's really small, don't worry. We have the NAND function. The output y is true if the inputs of A and B are true, else it would be false. This is the logic symbol to input A and B and gate and the one input and one output y. We have let's do a truth table. A and B 0 0 0 0 1 0. This is done 8 times B, okay? The y times 0 is 0, 1 times 1 is 1. The Boolean expression will be y is equal to A times B is equal to A times B is equal to AB. All the other function is on A plus B now. The output y is true if the input A or B is it's true, else it will be false is the logic symbol. A and B input or gate with the y output. This is the truth table. Input A and B 0 0 0 0 1 1 1 0 1 1 1 1 because 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1. And the Boolean expression will be A plus B. We have the NOT function, inverter, this is the bubble there, the reversible bubble. The output y is true if the input A is false, else it is false, y is the inverse of A. Logic symbol is A, one input, the one output, but you can see here we have the bubble there is called invertible. Let's check the truth table. 0 is 1, 1 is 0. The Boolean expressions y is equal to A bar. This is a not bar. We can use the alternative notation y is equal to A prime and y is equal to not with like this sign, like I don't know what it's called, I don't remember. Not A, I mean, in a programming language. Output y is false if inputs if A and B are true, else it is true. NAND. Let's check output y is false if inputs and A and B are true. Else it is true, else this is true. Okay. The bubble is inverted, this is AND gate without inverted output. NAND. Inverted AND. Okay, let's check the truth table. A times B is equal to 1. 0 times 0 is 1. 0 times 1 is 1. 1 times 0 is 1. 1 times 1 is 0 because this is the else, it is the false. If this is 0, it will be 1, okay? If this can be with N, A times B. 0 times 0 will be 0 on the end, but since we have inverted, it will be 1. Just remember the false, the reverse of it. 0 times 1 is 1, 1 times 0 is 1, 1 times 1 is 0. We have the NOR function. This is A plus B, but it will be the worst of it. From Z plus 0 would give us 0, but in this case, this invert will give us 1. The output y is false if the input A or B is true, else it is true. The logic symbol to input NOR, the inverted there, above is an inverter, these are given out with its output inverted. Let's check the truth table. 0 plus 0 is 1, 0 plus 1 is 0, 1 plus 0 is 0, 1 plus 1 is 0. So it means 1 input, 1 true, and 3 false. Y is equal to A plus B with the bar, the inverted bar. So we have XOR, exclusive OR gate. X, Y, and zeta. As you can see here, x, y, zeta, x in the power y. So zeta is equal to x in the power y. Okay, I see. So 0 to the power 0 is 0. Y. Okay, let's check. 1 to the power. I don't know. I'm sorry about this one. Did I say a mistake there? This is a x NOR gate. This is circuit to truth table example. A, B, and C. We've done this case, but we have test 8 combinations here. So let's check it. This comes 0. Don't worry, these are really complicated for me too. Don't worry. Circuit to Boolean equation. Y is equal to A, B plus C plus AC. AOI logic, AND gates or gates inverter gates. NAND gate special application, NOR gate special application, NAND implementation. I see. This implementation of half header. To be honest, guys, this is pretty difficult for me too. Don't worry if you are feeling weird. Just check other videos to check your work. These are basic Boolean identities. We might learn this one because these are really important. They are the basic Boolean identities. We have identity law 1x is equal to x, to AND form. Our form is 0 plus x equal to x. Oh my god. You have the now dominance law, 0 times x is 0, 1 plus x is 1. Idempotent law, x times x is equal to x plus x is equal to x. Inverse law, x times x is bar is equal to 0, x plus x bar is equal to 1. Commutative law, associative law, x times y multiplied by z is equal to x times yz. And the R form x plus y plus z is equal to x plus yz. Absorption, distributive law, x plus yz is equal to x plus y, all multiplies x plus z. Or form is x y plus z is equal to x y plus xz. Absorption law, x times x plus y equal to x plus De Morgan law, x times y prime x, okay, problem. Double compounded law, x double inverter is equal to x. This is the Morgan theorem. Not all variables change n to absolute value of n to end, not the result. We have some example here. We use algebraic simplification rule to reduce xyz plus xy z plus xz. We have a K-map, and the method for minimizing logic is used to represent the values and to a function to different absolute values. The rows of column in K-map correspond to the possible values of the function input. Here the K-map example. A integrated circuit is used for NAND. Here's the integrated circuit NOR gate. So let's check the pin description. It's really cool. We have here NOR gate, OR with an inverter here. It is called NOR. All these are NOR with the two input and output. Output gate, input gate, blah 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 blah. As you can see, we have 2 to 6 volts HC and 5 volt LC2 and HCT. 2 input and gate. As you can see, these are the AND gate. This is a Hex Inverter. This is the NOR gate. This is OR. No, this is an inverter. This is not gate. Yes, this is not, and the bubble here. Also, we have the answer. Thank you guys for checking it out. I'm pretty sure my dance a mistake there, but if there is, I'm gonna just write it down in the comments. Have a great time, guys. Sorry for taking this quick. Cheers, bye bye.